Amazing camera shots like this are nothing new to those of us SpaceX enthusiasts who have been watching the launches for some time. The launch process, stage separation, and the always thrilling landing process are all made spectacular by these incredibly detailed pictures. However, how do we manage to capture these breathtaking images? We are going to go right in and examine what initially makes a shot like this so challenging in this video. Additionally, we will discuss the equipment in use and its historical history. Let us say you have a camera and you want to record a rocket traveling at 5,000 kilometers per hour from 60 kilometers distant. First off, you can only get a maximum focal length of roughly 1,000 millimeters with a typical telephoto lens. You would need a lens with a focal length at least 10 times that of a rocket that is 60 kilometers away and 70 meters tall in order to fill the full frame. Second, the camera must pan upward in perfect time with the rocket to provide a smooth tracking shot like this one. The smallest adjustments made by the camera result in enormous motions at the other end, where the rocket is, so that is easier said than done. If you attempted to manually track the rocket with a regular tripod, this is how it would seem. What if you did not have a lens that was 10,000 millimeters in diameter? This is how it would seem. We need something far more precise and exact than a tripod and a long lens for a shot like this. SpaceX utilizes three primary launch sites. Launch Complex 4E at Vandenberg Air Force Base in California, Complex 39A at the Kennedy Space Center, and Complex 40 at Cape Canaveral. These launch sites all date back to the early 1960s and 1970s space era. A number of long-range tracking cameras that resemble this are placed around each launch pad. These are kineto tracking mounts, which were first created for military applications to locate missiles and airplanes. Such rigs would have been operated by a trained operator to track the Saturn V rocket as it rocketed into the sky during the Apollo era. In those days, maintaining the camera array's orientation depended on the operator's skill. Many tracking tasks are now automated or partially automated. An operator at mission control can simply operate these kineto mounts remotely. They can also take almost any camera you can think of and turn it into the priciest tripod in the world. In addition to providing excellent coverage of their launches, rocket companies utilize these costly tracking cameras to examine their rockets throughout the most challenging portions of their flights. On these mounts, NASA employs a combination of film and digital cameras. Rocket manufacturers may examine their rockets in great detail during the launch procedure by using the high frame rate and shutter speeds of the short-range tracking cameras. Additionally, they utilize a few infrared temperature cameras to gauge the spacecraft's heat during re-entry as it burns through the atmosphere. These kinds of cameras have been crucial to the investigation of disasters. The entire crew of the Space Shuttle Columbia was tragically killed when it disintegrated during re-entry as falling debris tore a hole in the spacecraft, as captured by tracking cameras. After analyzing the video, NASA implemented new protocols to make sure the shuttle could safely return to Earth's atmosphere. NASA claims that they even have a few film cameras positioned across their launch locations, each of which is stocked with more than 1,000 feet of film. Naturally, they also have the newest camera equipment, which allows them to broadcast live 4K video feeds to the entire world. We are able to watch these remarkably clear photos as they happen because of this. We have made great progress. That is it. It is actually quite challenging to record and broadcast a rocket launch. We should expect to see more incredible photos like this one when tracking system and camera technologies advance further. Make sure to subscribe so you can participate in the conversation as we learn more about everything space-related, and feel free to ask any questions you may have in the comments section below. I appreciate you watching, and I hope to see you in the next video.